In this video, we're going to talk about proofs and reviewing what we have talked about in the past with theorems and two-column proofs, but also adding in some properties about congruent triangles and how we know that triangles are congruent. So first off, we know that a proof is a logical argument that shows a statement is true. There are several formats of a proof, and the one we've talked about before is a two-column proof, which has our numbered statements like we've been working on and corresponding reasons. The types of reasons that we use in our proof are called theorems, and they can include definitions, properties, postulates, and theorems. So a theorem is a statement that can be proven, and then once we have proven something in a proof, then that's why we can keep on using those same theorems throughout the different proofs that we'll see in the future. Here is a list of all the different properties that we could see again. So some of you took notes on this previously and some of you have not. So reflexive, so if something is reflexive, we know that both sides of the congruent symbol are going to be exactly the same. For a segment AB, we know that segment AB is congruent to segment AB. You might want to put a star by this one because we're going to use this one quite a bit. The other properties are not going to be as common, so the next one is symmetric. So if AB is congruent to CD, then we can flip it, and it's going to be CD, so segment CD is congruent to segment AB. So the third one, transitive, we're going to see this one quite a bit as well. So if AB is congruent to CD, and if you notice, these parts are the same now, so then it starts if CD is congruent to EF, then we can tie the first one to the last one together. So AB is congruent to segment EF. So next is going to be pretty much the same thing except now with angles versus segments. So make sure you put a star by your reflexive and symmetric, reflexive and transitive again. So reflexive, remember, is going to be the same on both sides. So angle A is congruent to angle A. And then our symmetric, remember, we're going to flip it around. So angle B is congruent to angle A. And for the reflexive, if you want to put something there, it's going to be the same on both sides.
Is that like a mirror?
Well, yes, it is a mirror image. That was Miss Morris, if you were wondering. All right, so for transitive, we know that if the angle B and angle B are the same in both of those, we can tie together the A and C again. So we can see that A is going to be congruent to our angle C. So again, remember, make sure you are starring those special properties because we're going to see those probably the most often. All right, so before we've done two-column proofs, and we're going to see two-column proofs again. This time is going to be with congruent triangles, but for this example right here, we are just going to be using this proof to practice the properties that we just went through. So first, remember, we are given, and we know that the given statement goes first, so that part is already done for you. So next, one thing that is already on here is the segment addition postulate, and if you remember, segment addition postulate is we're going to add the pieces together, and it equals the whole segment. So if you look at our picture, they took AB and added it to BC to equal the whole segment of AC, and that's what it says right here. So that's segment addition postulate, so that's going to come up often as well. So if you don't remember that one, write down your definition so you can remember what it is. So next, what you want to notice is that since AB right here is the same as AB right here, so think of your transitive property, how you have two parts that match up together, and then we can say that the other pieces are going to be equal to each other. That's what they set up right here. So they took the AB plus AB from this first one, and then they took the AB plus BC. For the second one, we can say that those are equal to each other because what they were originally equal to are the same. So that's your transitive property. And since we have equal signs we're dealing with, it's going to be the transitive property of equality. If it was congruent symbols you see, you would write the congruent symbol. Then you have to think of, just like we did with our two-column proofs before, is what happened from 3 to step 4. And the part that they moved is all of a sudden one of these ABs are missing from each side, and it's because they subtracted AB from both sides of our equation. So because they subtracted, our reason is our subtraction property of equality, again, because we have our equal signs. And that's how they got to the final proof statement. For congruent figures and corresponding parts, we have talked about this before, so we know congruent figures means that they have the same size and same shape. We also know that all corresponding parts are going to be congruent to each other. So that means all the angles that match up, all the sides that match up will be congruent to each other. So that's what the corresponding parts means, is that we have corresponding angles are congruent, and we have corresponding sides that are congruent. So if you are given a congruent statement, right here is what that's called, that one triangle is congruent to another triangle, then we can match up the corresponding angles and corresponding sides, and that's what we're going to do right here with our two triangles. So we have to look at our two triangles to figure this out. I would say figure out the corresponding angles first, because the angles will help you lead into how to write your congruent statement. So if you look at our picture, our angle A is right here with a right angle. So the right angle that goes with it is our angle F. Next, angle B has one little congruent symbol, or congruent arc to it, and angle G also has the same congruent arc. So it's going to be angle G. And then angle C has our two little congruent arcs, and so angle H matches up the same way. So now when we set our congruent statement, we know that A goes with F, so F will be the first letter. And next B, we have G goes with that one, and then H is our corresponding angle that goes with C. So that's how you're going to write your congruent statement. So corresponding sides, I would say look at your statement to set that up. So remember, our AB is the first two letters, so the first two letters is FG. Then BC is the next two letters, so GH is going to be our segment. And then CA is the very last one to the first, so we're going to do the last one to the first again. So HA will be set up the same way. And if you look at your picture, you can line up the congruent symbols as well. All right, let me fix that. That was supposed to be HF. I can't read my own handwriting. There you go. So now we're going to see the reflexive property, the symmetric property, and transitive property, but now with triangles, not necessarily just angles or sides. So remember, reflexive property is kind of like a mirror image, so it's exactly the same on the opposite side, so A, B, C. Our symmetric is when we're flipping from side to side, so you can rotate what's on each side. So that would be DEF, so triangle DEF would be first, is congruent to triangle ABC. And then for the transitive property, remember the two of the pieces will be the same, and then we can say that the other parts will be congruent. So triangle ABC will be congruent to triangle JKL. Remember, your transitive property and reflexive property are the most common ones you are going to be seeing. So here's a proof we're going to set up with the triangles that are congruent. So first we need to go through the pieces that they give us. So that's up here at the very top. So FH is congruent to JH, and if you look in your picture, FH are the congruent lines that are one congruent line, and that ends up right here. So we know our first reason is always going to be given. Next, we also have the same, we have FG, so our two congruent lines with our two congruent lines in our picture already, and that again is our given, which we've already shown. There's also a few other things that they gave us, and that's these right here, so our different angles. So FHG, so if you look at our different congruent lines in our angles up there, and FGH and JGH, and that's really sloppy in the picture, sorry, but that ends up down here. So sometimes the givens don't always necessarily have to be the first two statements that are given, so they could be mixed around. So fill those in first because those are always the easiest ones to fill in. So next, we need to show that the two triangles are congruent. So all we know right now about congruent triangles is that all the corresponding parts have to be the same for the triangles to be congruent. So if you look in our picture, we're missing some pieces of information. We need to show that HG is congruent to HG, and the only way that we can do that is by using the reflexive property. So HG is congruent to HG, and if you notice, that's why I said that the reflexive property is the most common one you're probably going to be using, because you need it whenever the triangles are touching like that, so any side that they share. In the third angles theorem, that means that if we already have two angles that are congruent in both triangles, then we know that the third angle will also have to be congruent. And if you remember, the reason is because that all three angles have to add up to be 180 degrees. So if two of them are already matched up, then we know that if we subtract from 180, the remaining angle will also be congruent. So we know that F is supposed to be congruent to angle J. So in our proof, if you notice, the reflexive property is already set up over here, so we know that that's the piece that the side that it shares. So HG is congruent to HG. And then they gave us the reason again for our third angles theorem, and that was for this missing angle that we didn't already have from our other two angles. So we would put angle F is congruent to angle J. That one might be a little bit trickier. You're probably not going to see that as often that we're going to be writing it. So once we have that written in our picture, we can see that all corresponding parts are going to be congruent. And so that's our reason for why our two triangles would be congruent. And it's just the definition of congruent triangles. So if you notice on here, I wrote that all corresponding parts are congruent, but the real reason is it's our definition of congruent triangles.